Hello, everyone, and welcome to this explainer. Look, if your website is online, but your users, your QA tests, or your automated workflows are still failing, the issue might not be your core app at all. It could actually be the CAPTCHA layer. We all know the drill, right? You're trying to log in, and you're asked to prove you're human. But there's this entire invisible layer operating beneath those CAPTCHAs that evaluates you way before you ever see a puzzle. So today, we're going to pull back the curtain on browser fingerprinting and see how modern detection systems actually work. Okay, let's dive right into this. If signup drops, or your QA tests become inconsistent, or an internal workflow just starts failing out of nowhere, the first reaction is always to check the app. Is the site online? Yes. Is the API responding? Yes. Is the database healthy? Did a deployment break something? But sometimes everything looks totally normal and the workflow still fails. And that's because modern CAPTCHA systems do not just check if you clicked a box. They evaluate browser signals, behavioral patterns, environment consistency, and complex risk scores. So instead of treating CAPTCHA as just this random bit of friction, we really need to start treating it as a critical workflow reliability signal. Here is our roadmap for today's explainer. Section 1, Beyond the Checkbox. 2, Anatomy of a Fingerprint. 3, How CAPTCHAs score you. 4, Bot versus real browser. And 5, Reducing triggers. Let's get started. Section 1. Beyond the checkbox, the hidden trigger. So let's totally reframe how we think about CAPTCHAs. Imagine the system as this invisible bouncer standing at the door of a club, checking your digital ID for any suspicious inconsistencies before you even try to get in. It does this through something called browser fingerprinting. Essentially, it's collecting dozens of tiny data points from your browser to create a unique identifier, and it does this completely without cookies. It takes this invisible fingerprint and calculates a risk score, silently asking, does this environment look like a real, consistent human user, or is this an automated script? Section 2, Anatomy of a Fingerprint. What makes you unique? So what actually makes you unique to that invisible bouncer? Well, it's not just your user agent telling the website that you're on Windows. It goes way deeper. It looks at your canvas hash, which literally checks how your specific GPU renders graphics. It exposes your exact graphics card model, your screen resolution, your time zone, your installed plugins, and even the highly specific fonts installed on your local system. All these seemingly harmless elements combine into a super accurate profile, and the crazy part? You absolutely cannot hide this by just clearing your cookies. And this brings us to a huge mistake that teams constantly make, ignoring browser environment changes. Let's say you're running an authorized QA test from a server in Germany, right? So your IP geolocation is screaming German. But maybe the automated browser was installed with an English US locale language. Honestly, this is a massive red flag. When that invisible bouncer spots a mismatch like that, your risk score instantly spikes. Section 3. How CAPTCHAs score you. The evaluation systems. Let's break down how the major players actually do this, starting with the classic reCAPTCHA version 2. You know this one. It's the familiar I am not a robot checkbox. Here's how it works. First, it grabs your fingerprint the exact millisecond the page loads. Second, as you physically move your mouse to click that box, it's actively analyzing the trajectory and the acceleration of your mouse. Third, it checks your Google cookie history. And finally, it scores your risk. If everything checks out and you're low risk, you get an auto pass. But if you're medium or high risk, boom, you're hit with an image challenge. But you know, the landscape has evolved heavily. Enter reCAPTCHA version 3. This is the invisible iteration, and it's totally different. Instead of a checkbox, it just runs continuously in the background while you browse. It's constantly monitoring your fingerprint consistency and your behavior, grading you on a scale from 0.0, which means bot, all the way up to 1.0, which is human. The twist here is that the CAPTCHA system itself doesn't block you. It simply hands that score over to the website, and the site owner decides whether to let you through, block you, or ask for a secondary verification. Then we have Cloudflare Turnstile, which takes a slightly different angle. Turnstile relies heavily on testing your browser's underlying capabilities through really complex JavaScript engine tests. It basically verifies that your fingerprint matches the actual capabilities a real browser should possess. It analyzes your request patterns and usually only issues a challenge if it detects genuinely suspicious signals. So it's a lot less about how your mouse moves and a lot more about proving your browser's underlying engine is authentic. Section 4. Bot versus real browser, the tells. So how exactly do internal systems or bots get caught red-handed? Quick question for you. Does browser fingerprinting only affect malicious bots? No, absolutely not. It affects QA browsers, internal systems, and authorized automation anytime the environment looks unusual. Look at the data here. In a normal Chrome browser, a property called navigator.webdriver is undefined, but in a default headless Chrome setup, it broadcasts as true. It is literally shouting, "Hey, I'm an automated script." Plus, real users usually have a few plugins installed, automated setups usually have zero. These are the obvious tells that make spotting default automation incredibly easy. Section 5. Reducing CAPTCHA triggers. Mitigation strategies. Now, if you take only one technical fix away from this explainer today, make it this one. That navigator.webdriver flag we just talked about, it is the single biggest red flag you can possibly wave. Patching this in your automated environments is a non-negotiable baseline requirement. But, and this is crucial, simply playing a game of cat and mouse with technical flags is a huge mistake. You can't just patch a flag and call it a day. You need a properly managed operational strategy. For instance, you absolutely have to document what normal behavior looks like. Automated browsers notoriously default to weird, outdated screen sizes like 800 by 600. Guys, nobody browses the modern web at 800 by 600 anymore. Using realistic top market share dimensions like 1920 by 1080 is a great start. You need to record exactly what a normal, successful workflow looks like. Did anything change in the browser environment recently? Documenting this means your technical and ops teams aren't just guessing when something breaks. To manage all of this properly, you need a practical checklist. Step 1. Identify the workflow. Is CAPTCHA stopping a login, a checkout, or a QA test? Step 2. Define the impact. Does this failing workflow affect revenue or customer trust? Step 3. Assign ownership. Who actually owns the challenge rate monitoring? If nobody owns it, you will always respond late. Step 4. Document normal behavior, as we just discussed. Step 5. Monitor outcomes, not just uptime. Track the challenge rate, completion rate, and failure reasons. The question isn't just, is the website up? It's, can the intended user complete the job? And finally, step 6, create a fallback path. Because here's the reality. If a workflow is blocked and you don't have a fallback, your team is going to invent one in the middle of a live incident, and that creates massive extra costs. What manual process takes over when automation fails? Now, third-party solvers like CAPTCHA AI do exist to automatically manage these remaining friction points and keep workflows moving. But please remember, this kind of automated fallback should only ever be used in owned, client-authorized, or contractually permitted environments. It's all about making sure your authorized process has a safe path to completion. Which leaves us with this final, really important thought. The next time a CAPTCHA blocks your workflow, don't just ask, how do we bypass this? That's the wrong approach. Instead, ask, how does this verification layer affect our workflow? Who actually owns this risk? How are we monitoring it? And what is our responsible fallback path? Save this checklist for your next workflow review, especially if browser automation or third-party verification is part of your process. Thank you so much for joining me on this deep dive, and I'll see you in the next explainer.